Next, actually, uh, mention the expressions for self-inductance of a coil and define the terms. Mention the expression for self-inductance of a coil and define the terms. For 2 marks they will ask, or mention the expression for mutual inductance of a coil and define the terms. And uh, definition of 1 Henry, and what are eddy currents, and what are the uses or applications or advantages of that eddy currents. So I will erase this. How the question will come? Mention the expression for 2 marks they will ask. Mention the expression for self-inductance of a coil and explain the terms. Mention the expression for self-inductance of a coil and explain the terms. Mention the expression for self-inductance of a coil and define the terms or explain the term. See, that question is best suitable for 2 marks. Writing the expression is for 1 marks. Explaining or defining the terms is for 1 marks. So see, L is equal to mu naught n square A into L. This is the expression for self-inductance of a coil. You can just define or explain the terms. What is L? What is mu naught? What is N? What is A? And what is L? Small letter L. Here capital letter L and small letter L. Capital letter L means it is self-inductance. Small letter L is the length of the coil. So what is this capital letter L? So it is self-inductance. Mu naught, permeability. One more will come in the first topic, permittivity. Permeability of not, nothing is there, empty, free space. Permeability of free space. What is this N? N is number of turns. TURN. Don't write TRM. Terms, not dirty term. TURNS. Turns. Turns means how much times it is rounded or wounded. Rounded means wounded. In a coil, a spring, solenoid, many terms are there. Area of the coil. What is this capital letter A? Capital letter A is area of the coil. So small letter L is length of the coil. So this is for inductance, self-inductance of a coil. Similarly, one more will come. Write the expression for mutual inductance of a coil. And define the terms. So what is that expression? Here capital letter M is equal to, M means mutual inductance. Mu naught, mu r, both will come. Mu naught, mu r, N1, N2, pi r square L. This is the expression for that mutual inductance of a coil. So define the terms. What is this capital letter M? Capital letter M is, what is the capital letter M? Capital letter M is, what is the capital letter M? Mutual inductance. So capital letter M is mutual inductance. Capital letter M is mutual inductance. Mu naught, just now I wrote it. What is this? Mu naught is permeability. Mu r, the word R stands for relative. Relative permeability. Relative permeability. N1, number of turns of the first primary coil and secondary coil, and it will come like that, primary coil and secondary coil. So N1 means number of turns of the primary coil, N2 means number of turns of the secondary coil. So number of turns of primary coil. Number of turns of primary coil. Actually ನಾನು ತುಂಬ ಕಡೆ ಟ್ಯೂಷನ್ ಇದು ಮಾಡ್ಬೇಕಾದ್ರೆ ಇಂಕ್ ಪದೇ ಡಸ್ಟಲ್ಲಿ ಇನ್ನೂ ತಲೆ ಹಿಡ್ಕೊಂಡ್ಬಿಡ್ತಿದ್ದೆ. ಸ್ಟೂಡೆಂಟ್ಸ್ ಎಲ್ಲ ನಗ್ತಾ ಇದ್ರು, ಹಿಂದೆ ತಿರುಗಿ ನೋಡ್ತಾ ನಗ್ತಾ ಇದ್ರು, ವೈ ಯು ಆರ್ ಲಾಫಿಂಗ್ ಪಾಪ ಹೇಳೋಕೆ ಎದ್ಕೊಂತ ಇದ್ರು. ಇರಲಿ. ಸೊ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ ಆಫ್ ಪ್ರೈಮರಿ. ಸೊ N2 is number of turns. N2 is number of turns of secondary coil. Number of turns of secondary coil. R is the radius of the coil. Both mutual interaction. Actually, primary coil, they will consider it as a primary coil only, but both are inserted and interacted. Both the coils are wounded. So in generally, radius of the coil only we will take. R is the radius of the coil, and L is in generally, small letter L is length of the coil. Small letter L is length of the coil. Both primary and secondary coil, they will be equal length only. Both one by one inserted, both we will take. So this is actually the for 2 marks they will ask this question. Write the expression for self-inductance of the coil and define the terms, or write the expression for mutual inductance of the coil and define the terms. Like that they will ask actually. You can write the expression like this, and you can write down define the terms also. Okay. So next, define 1 Henry. See, actually in physics some definitions are there. Many are there like this. At least minimum one will come. Anyone definitely will come for main exam every year. How many are there in physics actually? See, how many are there in physics means, starting from the first topic I will say. Starting from the first topic, define ampere or 1 ampere. Define ampere or 1 ampere. Define farad. Define coulomb. After that, volt, 1 volt, or in generally volt, 1 volt. In the below 1 ohm resistance with respect to resistance, ohm, 1 ohm, or in generally ohm they will ask. Before all these terms you can just add 1 ampere, 1 farad, 1 coulomb, 1 volt, 1 ohm. Similarly Henry, 1 Henry. 1 watt, define watt. 1 watt, like this. What are they still? EMF, volt only, 1 volt, like this. With respect to resistance, ohm. With respect to capacitance, farad. Charge, coulomb. Okay, like this. In many, how many are there? 3, 7 are there. I think one more is there. I forgot that. Apart from this, for every year for main exam, at least one definitely will come. Define 1 ampere or define 1 farad. What is farad? Define 1 ohm. Define 1 watt, or what is watt? Define watt. Like that will come. Define Henry, like that. So you can please practice all these definitions just for 1 marks. Easily you can take that 1 marks and you can keep it inside your pocket. Okay, no one will capture, no one will thief. So I will just define that 1 Henry related to this topic. 1 Henry, how to define that 1 Henry with related to both self-inductance and mutual inductance. We know that small letter E is equal to L times of di divided by dt. Small letter E is equal to L times of di by divided by dt. When current changes at the rate of unity. When di divided by dt is equal to 1, current changes at the rate of unity. 1 ampere current changes in 1 second, 2 ampere current changes in 2 seconds, 4 ampere current changes in 4 seconds, like that. Then the induced EMF is numerically equal to the self-inductance. Why I have taken modulus means in equation actually minus will come. We will ignore that my negative sign in generally in many of the cases, but we will take modulus. Okay, the induced EMF is numerically equal to the self-inductance of the coil. Similarly, in mutual inductance also the induced EMF is numerically equal to the The induced EMF is numerically equal to the mutual inductance, like this. So then how to what is this 1 Henry? Define 1 Henry. Define 1 Henry. Or then how you will define this 1 Henry? How you will define this 1 Henry? So 1 Henry is the inductance of the coil. 1 Henry is the inductance of the coil when current changes at the rate of unity. 1 Henry is the inductance of a coil when current changes at the rate of unity. When current changes at the rate of unity. Whenever this current changes at the rate of 1 ampere in 1 second or 3 ampere in 3 seconds, then the induced EMF is equal to the numerically equal to the self inductance of a coil or mutual inductance of the coil. That is called as. Then how to define this 1 Henry? 1 Henry is the inductance of a coil whenever current changes at the rate of unity. Whenever current changes at the rate of unity. 1 Henry is the inductance of a coil when current changes at the rate of unity. That is the definition of 1 Henry. Next, the last eddy currents. What are eddy currents and that eddy currents applications? I will just explain that eddy currents definition and very important is eddy currents. Best to shoot up for 3 marks. Almost in for at least for 2 years once or every year sometimes continuously 3 years they have asked this question. What is that? What is meant by what are eddy currents? Please remember these all definitions. Eddy currents definitions and uses or applications of eddy currents. So the question is, what are eddy currents? What are eddy currents and applications? Eddy currents applications. Mention its uses. Mention or write its uses. So the circulating currents we will call it as circulating currents induced in a metal plates whenever the metal plates are moving in a varying magnetic field. The circulating currents, the correct definition is the circulating currents induced in a metal plate which is moving in a varying magnetic field. So just like motional EMF, their uniform magnetic field will come. Here non-uniform or varying. The magnetic field is not constant. In a varying magnetic field, you can take conductors or some metals, you can move them. Just you can move them, then currents will get induced in that metal plates. Those are called as eddy currents. You can say the correct definition. The circulating currents induced in a metal plate which is moving in a varying magnetic field. Those are called as eddy currents. I will write the definition. The circulating currents currents induced in metal plates. Don't use A because plural form I'm writing here. Induced in metal plates due to varying magnetic field. Due to varying magnetic field. Currents I have used are called eddy currents. Are called eddy currents. What are the applications of these eddy currents? What are the applications of these eddy currents are used in a induction furnace? You know induction furnace and induction coils. This electric stove will come. That coil, rounded one coil is there. That will work in the principle of mutual induction actually. Electromagnetic induction, this topic. Mutual induction, electric stove, induction stove, that and all will work in on the base on the principle of that mutual induction. So induction furnace, in the induction stove, anything you can write. The induction furnace, induction stove, or no problem, induction stove. Magnetic braking. Magnetic braking, usually where we will use this? In trains. Magnetic brakes. In train we will use this magnetic brakes. Induction furnace, magnetic brakes, electromagnetic damping, and deadbeat galvanometer. Electromagnetic damping, deadbeat galvanometers. Can write any 2 or 3. Anyway, maximum they will ask for 3 marks only. For definition 1 marks, you can just write any two users 1 plus 2 3. So these are the applications of that eddy currents. They will use in induction furnace. Magnetic brakes, electromagnetic damping, and deadbeat galvanometer. Some more, 2 more are there. No problem. Is that problem? Okay. For today, I will stop it at here. So in this topic, the pending is one important problem is there for 2 marks. Very important problem. I will do that problem in the next class. After that, 2 experiments are there. Coil and coil magnet. 2 experiments are there. One Lenz law statement is there. Coil and coil magnet experiment. 2 marks. One important problem is there for 2 marks. Very important one. In CET and sometimes in NEET also they have asked that question. And that AC generator, how it will work, and diagram AC generator I will explain. In one class maximum I will complete this topic. After that I will discuss some important questions, topic wise important questions I will discuss. And in 10th also, some topic is some important questions I will discuss. Okay, thank you. I will upload this video in YouTube. Thank you.